dichlorine monoxide, so 1 oxygen with
And
2
2 chlorines.
And I probably have to figure out if it's, so there's 6, and then chlorine is, so 14, so there's 20. Is that, what do I say? Is that 20
Electrons.
electrons? Okay.
Valence electrons.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So
Yes.
there's 2 lone pairs.
Yes. So we know the molecule is not symmetric.
So even though there's 2 chlorines, because I have 2 lone pairs, it means it's not
Not
symmetric.
symmetric.
So the only way it can be symmetric is if it's got the same on both sides or all the way around and no lone pairs.
Yes.
Okay. So I know that it's, is that shape bent?
Bent.
Oh,
Yes.
Yay! So that's bent. And because it has those lone pairs, I know that it is not polar. It is polar.
It is polar
So
because we have the lone pairs associated with the central atom. It is polar.
So the only time it's not polar is if it's symmetric.
Yes.
Okay.
And in order to be symmetric, all atoms connected with my central atom needs to be the same and no lone pairs in the central atom.
Anything. Okay. So the nitrogen, so just 2 N's. The nitrogen is 5, so 10. Oh, I hate it when there's just 2. I never. No, 2, 4, 6, 8, 10, 9. There's going to be a triple bond, huh?
Yes.
And then 2,
Lone
4,
pairs.
6, 8, 10. Okay, so even though they're the same, there's 2 lone pairs.
But do we have a central atom?
We don't have a central atom. So if you don't have a central atom, it can't be symmetric.
Well, it can,
Oh,
because if I have this and this, I can have a mirror here, and I will see the same thing in both sides.
okay.
So it is symmetric.
Well, it is symmetric. Even though I have the two lone pairs on.
Yeah, because this is not the central atom. This is not the central atom.
So it just has to be on the central atom.
Yeah.
Oh, okay. So this is symmetric, so it's London.
Yes.
Yay! Figuring it out. I just want this to stay in my mind for a little bit longer, please. Okay, so carbon, tetrachloride, so tetra is 4, and so that will be symmetric, so it'll be London.
Yes, you're getting there.
Polar. So, oh, nitrose chloride? I've never even heard of that before. Okay, so I know that my oxygen, no. So if there's no hydrogen, it's just NO, Cl.
Yes.
I can put it in the order like that it gives
Yes.
me. Okay. There's 2. Okay, so
Is the molecule symmetric?
no.
Do you have lone pairs associated with the central atom?
No, why not? Hold on. I guess I have to figure that out. 1, 2, 3, 4. So 5. What's next? What's that? So there's 18 valence electrons. 2, 4, 6, 8, 10, 12, 14, 16. Oh no, how do I do that? 16. Can I make a double bond right there and then take one away from the side of chlorine?
No.
No.
you have
Has to be a
5 plus 6, 11, so 18. So 2, 4, 6, 8, 10.
12, 14, 16, 18.
Yes.
Okay. I guess that's where I get confused, where I'm like, why can't I just erase that one of them from chlorine, and put it right there so I don't have a lone pair?
Okay, first, this guy needs to be in the center, the nitrogen.
Oh.
Because nitrogen needs 3 bonds to be happy. 3 electrons.
Oh, I didn't know that mattered. It only needs 3?
Yeah, and now you need a lone pair in the top there. Good.
Okay. So, how do you know when you can't just move that one right there?
Think about, I have $1 and you have $1. And I say, if your dollar and my dollar, if we combine them, we can buy ice cream and share.
Mm-hmm.
Right? So now, I have $2 and you have 0.
That's sad.
Do you think I want to give my $2 for you so you could buy ice cream?
No.
No. It's the same thing here. This guy here has 1 and this guy has 1, so I just said let's combine. But now that I have 2 here, I don't want to just give you for free.
Oh, okay.
I'm like, some atoms like oxygen and fluorine, they are so strong. They say if you don't give me, I'm gonna punch you and take away from you. It doesn't matter what. So they will force these guys to make double bonds. But the other ones is really like, can you share? No, I don't want to share.
Yeah,
my
because
ass.
I was confused because, like, in a way, like CO2, we just did double bonds right there.
Because I have 2, I need 2 electrons here and I need 2 electrons there.
Mhm.
But really, if I have only 1 electron here and I was missing something for the carbon, none of these oxygens would give it because they're stronger than the carbon. They would say like, no way I'm
Oh,
gonna give
is
you
that where we talk about, like, these ones up here have the highest
electronegativity. Therefore, they can steal electrons from someone else.
Okay.
But the other guys are like the normal guys, the skinny guys that doesn't go to the gym.
Mm-hmm.
They just are like, okay, I'm willing to share.
Okay. So chlorine is oxygen stronger than chlorine?
Yeah. Fluorine,
alkaline.
oxygen, and nitrogen are the strongers.
So it can make that double bond.
On here, because nitrogen needs 3 electrons to be happy, right? So this guy needs 2 and this guy needs 1. So 1 bond makes 1 electron, this guy with 1 this make this 2. 1 electron from this plus 2 electrons from this make the 3. And this your 2 electrons make the 2. So they are happy in that configuration with the lone pair. But if I really need more electrons and I need to steal it from someone, then if this guy is the central one, they just pull it. Doesn't matter what.
So even though nitrogen needs 3 to be happy, we still want 4 valence electrons around it. Like the one above it, the 1, 2, 4, or
Yeah.
8.
Because
I
it's-
mean, I
yeah.
forget they're counted as double.
Yes.
Okay.
This happens, in organic chemistry. Usually have a water there. Water has a plus charge, and this guy is like, okay, this guy is happy. The hydrogens are happy, but this oxygen are not. They are like, I'm missing 1 electron. What they do? They just break the bond. They're like, whatever. They break the bond and stole the electron from this guy, making a really cation, really unstable. But they're like, I'm more strong. I'm gonna stole the electron. Doesn't matter what.
It's vicious.
Yeah.
So this isn't symmetric, but there is a lone pair on my central.
And it's not symmetric. It has a lone pair and has this guy here is really polar bond. So then
it's a dipole.
it's a dipole.